So this is lesson 6 in Math 21, outcome 4. And we're going to build on what we did in the last lesson to include a ratio for volumes. So in the last lesson, we learned that if the scale factor is a to b, that means that the ratio of the area would be a squared to b squared, which means the ratio then of their volumes is going to become a cubed to b cubed. So first one, it says if the scale factor of two similar solids is 3 to 4. So that is my a to b. If I want to find the ratio of their surface areas, right, area is a squared then to b squared. So I'm going to have 3 squared to 4 squared. 3 squared is 9. 4 squared is 16. Now, what is new to us is then the ratio of their volumes. Well, that first slide said that if we want to find volumes, it is then a cubed to b cubed. So my a is 3 and my b is 4. And now I grab my calculator and I punch in 3 to the power of 3. You should get 27. 4 to the power of 3 is 64. All right, next example. It says, if the ratio of the volumes, so volumes means a cubed to b cubed, determine a, their scale factor. So this is going to be very similar to when we found the scale factor given the areas. If you are given the volumes, you're not going to take the square root now because we're not squaring a and b. Because we're cubing a and b, you want to take the cube root of each of these values. So again, you would grab your calculator. The cube root of 8 is 2, and the cube root of 125 is 5. So I get a ratio of 2 to 5. It then says, what is the ratios of their surface area? Well, if you want surface area, it is a squared to b squared, which means I need to use the scale factor, a to b, which is 2 to 5. So what I do then is I plug in my a as 2, and I plug in my b as 5. 2 squared is 4. 5 squared is 25. And there's our first, or our second question. All right, third example. It says each pair of objects is similar. A says, by what factor is the surface area of the larger greater than the surface area of the smaller? And then B says, by what factor is the volume of the larger greater than the volume of the smaller? So what I want to do, first of all, is figure out a scale factor. So it wants the larger one to the smaller one, so we're going to put the larger first, smaller second. So that would be my scale, right, that's a to b, is now going to be 3 to 1.5. Now I know that I can divide both 3 and 1.5 by 1.5, so I'm going to reduce this to make my math a little bit easier. And so I get a scale factor of 2 to 1. Now A wants to know what is the ratio of their areas. So remember, areas is a squared to b squared. So my a is 2 and my b is 1. 2 squared is 4. 1 squared is 1. So that was my area. B wants volume. Again, to find volume, it's a cubed to b cubed. My a being 2 and my b being 1. 2 cubed is 8. 1 cubed is 1. And so my answers are 4 to 1 and 8 to 1. We're now going to do the second. The second is 2 cones. So again, the first thing I need to know is my scale, which is a to b, which are just sides. So 5 would go with the 3. So I know my scale is 5 to 3. I can't reduce that, so now I'm going to work through. A is my area, and we were taught that that's a squared to b squared. A being 5, b being 2, or b being 3. 5 squared is 25. 3 squared is 9. So my answer is 25 to 9. For my volume, again, it's a cubed to b cubed. So my a being 5 and my b being 3. 5 cubed is 125. 3 cubed is 27. So I have 125 to 27. So that concludes practice 6. You now should work on lesson 6, now work on practice 6, and then when you're done that, there is a hand-in assignment to get you ready for your assessment.